Hello dear students, in previous video we discussed about the relation between the object distance, image distance and focal length. Students, we know that light travels in a straight line in isotropic medium. You know that isotropic medium is nothing but the light has the same speed in all the directions. Then such a medium is called as a isotropic medium. We know that in isotropic medium, light travels in a straight line. The free space is the one of the example for isotropic medium. Free space means vacuum is the one of the example for isotropic medium. But in some cases, we will observe there is a change in path of light. That means there is a bending of light. Then that type of phenomena is called as a refraction of light. So in today's class, we are going to discuss the phenomena refraction of light. Refraction of light. Then what do you mean by refraction of light? Refraction of light is nothing but it is the phenomena of change in path of light as it travels from one medium to another medium. Then it is called as a refraction of light. So refraction of light is nothing but the phenomenon of change in path of light as it travels from one medium to another. Then that phenomena is called as a refraction of light. So here we will observe there is a change in path of light when it travels from one medium to another medium. Here medium means it is the optical medium. So optical medium means the light which travels through that medium. Then that type of medium is called as optical medium. For example, air medium is the one of the example for optical medium. That means the light travels through air medium also. And glass medium also a example for optical medium. You know, glass medium also we can observe there is a transfer of light through the glass medium. So there are so many examples for the optical medium. So when the light travels from one medium to one optical medium to another medium, then we will observe the bending of light or change in path of light. Then that type of phenomena of light is called as a refraction of light. Now let us see how the refraction will takes place in different mediums. Now I am going to take here two medium. One is the air medium. This is the air medium. And another medium I am going to take. This one is the glass medium. Okay, there are two mediums I am going to take. And in between air medium and glass medium, there is a boundary. That boundary is called as an interface. That means it which divides this line which divides the air medium and glass medium, and that line is called as an interface. So here there are two mediums I am going to take. Now I am going to incident a light from one medium. So one medium means air is the one medium. So from air medium I am going to incident a light. So now I am going to incident a ray of light from air medium like this. Okay. So this is the incident ray. Now I want to know suppose that if I want to know the angle of incidence, then I should draw on normal. So how to draw the normal? I have to draw a normal which is perpendicular to the interface at the point of incidence, and that normal should touch the point at which the incident ray meet on the interface, and that normal should be perpendicular to this interface. This is the normal. So this normal is drawn to get the angle of incidence now. So we know that angle between the incident ray and normal is called as the angle of incidence. This is I. This is the angle of incidence. Now I am here incidenting light from air medium. When it is hitting to the interface, then it should travel to the glass medium also, because we know that glass medium also is one of the optical medium. That means in glass medium also light can travel. So now it will change its path. When it is entered to the glass medium, it will change its path. That means we will observe there is a bending of light. Actually it should go like this. Actually it should go like this straight. But instead of that, it is bending when it enters to the glass medium like this. So now there is an angle between the normal and refracted ray. So this ray which bends in another medium is called as refracted ray, and the angle between the normal and that refracted ray is called as angle of refraction. Sorry, this is the angle of refraction, angle between the normal and refracted ray. So that type of phenomena of light is called as refraction of light. So here I am going to incident a ray of light from air medium. When it hits to the interface, then it should travel to the another medium. The another medium here is a glass medium. When it enters to the glass medium, it will undergo the refraction. It will undergo the refraction means there is a change in path of light. That means here light is going to bend, and the angle between the normal and refracted ray is called as angle of refraction. Now, if you observe here, there are two mediums I am going to take. And here, air medium is considering as a rarer medium and glass medium is considering as a denser medium. Then what do you mean by rarer and denser medium? So air medium here I am taking as a rarer medium. Then rarer medium means rarer medium. Rarer medium means it is the medium. It is the optical medium. It is the optical medium in which light travels. In which light travels with high speed. With high speed. Then that type of medium is called as air medium. In this case, that type of medium is called as a rarer medium. In this case, air is an rarer medium, because if you compare to the air and glass medium, in the case of air medium, light will travel with high speed. So that here I am considering air as a rarer medium. And glass I am considering here as a glass medium, I am here considering as a denser medium. Then what do you mean by denser medium? Denser medium means it is the optical medium in which the light travels with less speed. Light travels with less speed. Light travels with less speed compared to the rarer medium. So here in the case of glass medium, the speed of light is less compared to the speed of light in air medium. So that it is called as a denser medium. And here mainly there are two conditions of bending. When the light travels from rarer to denser medium, then the refracted ray will bend towards the normal, and when the light travels from denser to rarer medium, then refracted ray, then the light will bend away from the normal. Okay, this is very important. So now let us see how the bending takes place in two mediums. Suppose that the conditions for bending of light is, so first condition for bending of light. Now you take two mediums, one as air medium, this is an air medium, another one is a glass medium. Two mediums we are going to take, and this is an interface. Now I am going to incident an ray of light from air medium. We know that in these two mediums, air medium is the rarer medium. because in the case of air, light will travel with high speed. In air medium, light will travel with high speed, so that this is an air medium as a rarer medium, and glass medium is a denser medium. It is a optically denser, that means light travel with less speed compared to the air medium. Now I am going to incident a ray of light from rarer medium to denser medium. So that I am going to incident a ray of light from rarer medium. So this is the incident light. Incident light. And to get the angle of incidence and angle of refraction, I have to draw one normal. So I am drawing one normal. That normal should be perpendicular to the surface or interface, and that normal should be join the point in which the incident ray meet on the interface. So now this is a normal now. It is not a ray, it is just a normal. This is the incident ray. Now when the light travels from rarer to denser medium, then after refraction the light will bends towards the normal. Light will bends towards the normal. That means when it enters to the glass medium, it will bend near to the normal. Okay, it bends very near to the normal in this condition. This is the angle between normal and incident ray is called as angle of incidence, and after it is entering to the denser medium, it will bends, and that bends nearer to that of normal. Okay, so this ray is called as a refracted ray. This ray is called as a refracted ray, and it bends very nearer to the normal, and the angle between the normal and refracted ray is called as an angle of refraction. This is the first condition. This one we will observe when the light incident from rarer medium to the denser medium. Another condition is there when light incident from denser medium to rarer medium. The condition is that now I am going to incident a light from denser medium to the rarer medium. So here also I am taking one interface, and now this one is I am taking as a glass medium. This is a glass medium, and this one is the air medium now. Okay, this one is the air medium. We know that. So in between the glass compared to the glass medium and air medium, glass medium is the denser medium. Glass is the denser medium, and air medium is the rarer medium. Rarer medium. Now I am going to incident a light from denser to rarer medium. Now I have to incident light from glass medium like this. This is the incident ray. And here also I am going to take one normal to get the angle of incidence and angle of refraction. Okay. So when it enters to the rarer medium from the denser medium, then the incident ray will change its path, and that will bend away from the normal. That ray, refracted ray, is like this. They are not now, in this case, the refracted ray is not nearer to the normal, and it bends away from the normal. And the angle between the normal and refracted ray is called as angle of refraction, R. And here the angle between incident ray and normal is called as angle of incidence. These are the two main conditions we will observe in the case of refraction. The first one is when the light incident from a rarer medium to denser medium, then the light ray bends towards the normal. When the light is incident from denser to rarer medium, then the light ray, after refraction, the light ray bends away from the normal. Okay, so that is the main two conditions of refractions. Now we will discuss the laws of refraction. Dear students, we already discussed about laws of reflection. In that we studied there are two laws of reflection. Like that, here also in the case of refraction, there are two laws of refraction. Then we will discuss the first law of refraction. The first law states that the incident ray, refracted ray and normal drawn to the interface at a point of incidence all are lie in the same plane. That is called as the first law of refraction. This law is similar to that of one of the law of reflection. Then what do you mean by this law? See here, I am taking here two mediums. So one is the rarer medium and another one is the denser medium. Now I am going to incident a ray of light from rarer medium, and when it travels to the denser medium, it will bend towards the normal. The angle between the normal and incident ray is angle of incidence. The angle between the normal and the refracted ray is angle of refraction. Now here if you observe the incident ray, normal and refracted ray all are lie in the same plane. For example, if you take this board as one of the plane, and you will observe all the three terms, that means incident ray, normal and refracted ray only on the board, and this incident ray will not come out from the board. Similarly, refracted ray also not come out from the board. Now I am not drawing normal also out of the board. All are lie in this board. That means here board is one of the plane. That means here incident ray, refracted ray and normal drawn all are lying in this plane only. Okay, so that is the first law of refraction. Now we will discuss the second law of refraction. So what is by second law of refraction? So it states that the ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of medium, and for a light of given wavelength. This is the second law of refraction. So this is a little different. So what is the second law states here? The ratio of sine of angle of incidence to the sine of angle of refraction is always constant for a given pair of medium and for a light of a given wavelength. See here, the angle between the normal and incident ray, that one is I. The angle between a refracted ray and normal, that is R. If I take the ratio of sine of I to the sine of R, then I will get one of the value. That value is always constant for a given pair of mediums. And another condition is that it is for a light of a given wavelength. Okay, I will get one value. That means if I take sine of the angle of incidence, that is I, to the divided by sine of angle of refraction, that is sine R. Both are the angles. So I will get one value after dividing. That value is constant. For a given pair of a medium. So that is constant for a given pair of medium and for a given light of a particular wavelength. That is also very important. That means if I consider rarer medium as a air medium and denser medium as a glass medium, this is the one of the pair of a medium, and I am going to incident a ray of light. That light has one particular wavelength. For example, you take 598 angstrom. This is the wavelength of a ray of light which is your incident. Just assume like that. Then you will get one value when you divide sin I when you take sin I divided by sin r. Okay, that is a fixed value. Suppose that if you change the angle of incidence for a same condition means for a same pair of medium and for a same wavelength of light. If you change the angle of incidence, okay, if you change the angle of incidence, then the angle of refraction also changes. But the ratio of a sine of angle of incidence to the sine of angle of refraction will not change. That means if you incident light like this, you are going to incident a light like this. So this is the light you are going to incident. But now the angle of incidence is changed. Now this is the angle of incidence. And here also the angle of refraction also changes. Okay, angle of refraction also changes. But the medium, pair of medium is same. The incident light ray has the same wavelength, that is 598 only. Then in this case, if again I will take the ratio sin I by sin r, again I will get the constant value only. For suppose that if I take air and glass medium, then I will get some of the constant value, that is 1.5. This is the constant value I will get. Suppose again if you change the angle of incidence, then again you will get another value of angle of refraction. That is not same as that of the angle of incidence. Suppose that again if you divide sine of angle of incidence to the sine of angle of refraction, again you will get 1.5 only. And the condition is the medium should be same, that is air and glass, and the wavelength of light should be same. Okay, here the pair of medium and the wavelength of light is very important for a given pair of medium. Okay, so that is the second law of refraction. Sine of angle of incidence to the sine of angle of refraction is constant. Suppose that if I, instead of a glass, if I take water, water medium, here the constant value will changes because here the medium is changed. Suppose that if the light has the wavelength 598 angstrom only, but the value of constant will change because the medium changed here. One of the medium is changed here. One of the medium here is water medium. Then the sin I by sin I r, I will not get a same that of 1.5. I will get some another value that may be 1 point something, 1.3 like that I will get for a given pair of medium. So for different angle of incidence and different angle of refraction, the sine of angle of incidence to the sine of angle of refraction, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, so that is about the second law of refraction. And that constant value, this constant value is called as refractive index of the medium. Refractive index. Refractive index. Then what is my refractive index? Here index means this is the number. Okay, so number, it gives the one of the value. Because of refraction we will get the one of the value for the pair of a medium. So that one is called as a refractive index. So now how to find the refractive index of the medium with respect to the another medium. So here we are getting the value because of refraction. Here refraction takes place not because of one of the medium. With respect to another medium, here refraction takes place. So I am getting the one value with respect to the another medium. So I have to take a refractive index of one medium with respect to the another medium. Here, suppose that here it has two mediums, air medium and water medium. The first medium I am taking it as air medium and the second medium I am taking as water medium. Here refraction takes place in the second medium. Okay. With respect to the second medium, refraction takes place in the second medium with respect to the first medium. So that I have to take the refractive index of a second medium with respect to the first medium. In which medium refraction takes place with respect to that another medium. Like that I have to take the refractive index. That means here I am getting the refraction in the water medium, that is the second medium. Refractive index we are normally indicating letter N. Okay. So refraction takes place in the second medium, that is the second medium is the water medium. So that I am taking N2, and refraction takes place with respect to the first medium. First medium is air medium. So I am writing N21 like this. This means refractive index of a second medium with respect to first medium. So refractive Ri, I am writing refractive index of a second medium with respect to first medium. Okay. Here you are going to incident a ray of light from first medium. Then when it is entered to the second medium, refraction takes place. So refraction takes place in the second medium with respect to the first medium. So that you have to take the refractive index of second medium with respect to the first medium. So that constant value also equal to refractive index of second medium with respect to the first medium. That will you get one constant value. How you will get constant value? Because of taking the ratio of a sine of angle of incidence to the sine of angle of refraction. Sine of I divided by sine of R. So that you are getting one constant value. That constant value only calling as a refractive index N. But here I am taking refractive index of second medium with respect to the first medium N21. So like that I can take refractive index of first medium with respect to the second medium. Suppose that here in this case you are taking two mediums. Again you are taking two mediums. One is the air medium, another one is the glass medium. Air medium and glass medium. So this is the normal. We know that this is the normal. Now suppose that say in the first case you have taken this is the incident ray, right? So this is the incident ray, this is the refracted ray, like this. Now you are going to incident a ray of light from glass medium to air medium. Okay, from glass medium to air medium. Now this is the glass medium. From glass medium we are going to incident a ray of light. Now this one is the R. You took this one as a R. But here now R is the angle of incidence. When the light travels from denser medium to rarer medium, then we know that the light will bend away from the normal. It should bend away from the normal like this. Now this I is nothing but angle between the angle between the normal and the refracted ray. That means here now I is an angle of refraction. Okay. Now I am taking a reverse case of the first diagram. Okay. Now I am going to incident a ray of light from second medium to the first medium. Okay. Second medium to the first medium. In second medium, in previous diagram I took the angle as a R. Now this R is the angle between the incident ray and normal. So that now R is the angle of incidence. When it enters to the first medium, then it will bends away from the normal. Okay, because I am incidenting light from denser to rarer medium. Now this I is nothing but the angle of refraction in this case. So we can incident light in a reverse case also. Okay. So now here I is angle of refraction. And R is angle of incidence. Because now you are incidenting light from second medium to the first medium. In this case, how to take the refractive index? That means how to take the constant value. So here the refraction takes place in the first medium, right? You are incidenting light from second medium and the refraction takes place in the first medium. So that you have to take the refractive index of a first medium with respect to the second medium. So you have to take where the refraction takes place. With respect to the another medium, you have to take the refractive index. That means the refractive index of a first medium. Here the refraction takes place with respect to the another medium, that is the second medium, N12. Refractive index of first medium with respect to the second medium, that is equal to sine of the angle of incidence. Now sine of the angle of incidence in this case is R. That means sine R. The ratio of sine of angle of incidence to the sine of angle of refraction. Now the angle of refraction is I sine of I. So this is the refractive index of first medium with respect to the second medium. This is the refractive index of the second medium with respect to the first medium. So that I can write N21 is equal to 1 by N12. So N21 is equal to 1 by N12. This is the reciprocal negation. So that is about the refractive index of the medium. Refractive index of the one medium with respect to the another medium. In the case of refractive index, we will consider there are two types of refractive index. That is the relative refractive index and absolute refractive index. So relative refractive index. First one is the relative refractive index. Relative refractive index means refractive index of one medium with respect to the another medium which is not a vacuum. Then that type of refractive index is called as relative refractive index. So relative refractive index is nothing but a refractive index of one medium with respect to another medium which is not vacuum. That is called as a relative refractive index. That means you can take any two medium and that ratio, that means the refractive index of one medium with respect to the another medium which is not vacuum. That means here you can take two mediums, air and glass medium, but it should not have, one of the medium should not have the vacuum medium. You can take any two medium excluding the vacuum medium. So that type of refractive index is called as a relative refractive index. You can take air and glass, air and water, glass and water, but you should not take a vacuum medium. Okay, so then it is called as a relative refractive index. Refractive index of one medium with respect to another medium, but it is another medium which is not the vacuum medium. That is the relative refractive index. Another one is there, absolute refractive index. Absolute refractive index means refractive index of one medium with respect to the another medium which is the vacuum medium. Then that type of refractive index is called as absolute refractive index. That means if you take one of the medium as air medium, another medium you should take the vacuum medium. Okay, then the refractive index is called as absolute refractive index. Suppose that if you take one medium as glass medium, another medium should be vacuum medium, then it is absolute, then the refractive index is the absolute refractive index. Okay, so this is the one of the way of finding the refractive index of the medium. And instead of this, another way of finding the refractive index also. So that way is by using the speed of light. we can find the refractive index of a medium also. How we can take the speed of light? Here also we are going to take the ratio of speed of light. Then also we will get the refractive index of the medium. By using the ratio of speed of lights, we can find the refractive index of the medium also. How to take? See here, in this diagram, there are two mediums. One is the air medium, another one is the glass medium. I am incidenting light from air medium and it is enters to the glass medium. So when it, suppose that I am going to incident light like this. Now I am going to incident light from air medium like this and it enters to the glass medium like this. Okay. So it bends towards the normal. It bends towards the normal like this. Like this. Now I am incidenting light from first medium. When incidenting light in a first medium, air medium, that is the rarer medium. In first medium, light has a maximum speed. Okay, maximum speed compared to the glass medium. When it enters to the glass medium, the speed of light is less compared to the air medium. That means in air medium, you have one speed of light. That means you will get the speed of light as V1 in the air medium. In the glass medium, you will get the speed of light as V2. That means in the air medium and glass medium, the speed of light is different. Then, using this speed of light, we can find the refractive index. How to take the value or how to take the ratio. Now, I am going to find the refractive index of second medium with respect to the first medium. Refractive index of second medium with respect to the first medium. To find the refractive index of second medium with respect to the first medium, I have to take the ratio of speed of light in first medium, ratio of speed of light in first medium to the speed of light in second medium. Speed of light in first medium is V1 divided by speed of light in second medium is V2 divided by V2. So like that also we can find the refractive index of second medium with respect to the first medium. We know that refractive index of second medium with respect to first medium is sine of angle of incidence, that is sine I divided by sine R. Right. N21 is equal to this N21 also can be written as N2 divided by N1. We can write N21 is equal to N2 divided by N1, that is equal to V1 by V2, that is equal to sine I by sine R. Sine I by sine R. So this is one of the another way of finding the refractive index. By taking the ratio of speed of light also we can find. This is the refractive index of second medium with respect to first medium. Like that we can find the refractive index of first medium with respect to the second medium. Here I have to take the ratio of speed of light in second medium, speed of light in second medium to the speed of light in first medium. If I take the ratio of speed of light in second medium to the speed of light in first medium, then I can find the refractive index of first medium with respect to the second medium. That is equal to, we know that sine R divided by sine I. Sine R divided by sine I. So that is about the refractive index and about the loss of refraction. And this loss of refraction is also called as Snell's law of refraction. This law is also called as Snell's law. Snell's law of refraction. And in one case, Snell's law of refraction fails. Which case that one? Suppose that if you incident a ray of light normally, then angle of incidence is equal to the angle of refraction. That means if you incident a ray of light like this normally, if you incident a ray of light like this along the normal, then there is no bending of light occurs. It will travel as it is. That means here angle of incidence I is equal to 0, angle of refraction R is equal to 0. In this case only, angle of incidence and angle of refraction is not same. So when we incident a ray normally, then angle of incidence is not equal to angle of incidence and angle of refraction is same. That means if I is equal to 0, R is equal to also 0 when light is incident normally. In this case only, the Snell's law will fails. So that is about laws of refraction or Snell's law of refraction.